Okay, hello everyone. I'm Xianhao Liu from Department of Civil and Construction Engineering, China University of Technology. My topic is sunshine simulation and scheme selection for the symbiosis of fission and electricity based on beam. The following 4 points will be used to outline this research. And the first is introduction of my topic, and the second is literature review, and the third is research method, and the last is conclusion. Introduction. Fission electricity symbiosis is the process in which solar facilities are combined with aquafarming. By installing them on the water or fish pond to achieve high land use, the ponds receive long duration of sunlight and are thinly shaded. Therefore, if the Taiwanese government gives proper consideration to generating solar power where aquafarming takes place, this can help to address the energy issues facing the island nation. In this study, a beam and a sunlight simulation method were developed and analyzed the number of hours of shading sustained by fishery electricity symbiosis facilities on the summer and winter solstice. Based on the result, an improvement was proposed, which is expected to increase the power generation efficiency of fishery electricity symbiosis facilities. Literature review, and part A is impact of shading on solar energy. To ensure efficient power generation performed of fishery electricity symbiosis, it is necessary to consider any potential shading that solar facilities may sustain, as they should be operated where they can receive as much sunlight as possible. This involves taking into account the impact of shading on solar facilities when they are being designed. And part B is beam-based solar analysis of fishery electricity symbiosis. To collect data such as sunlight amount, a beam for fishery electricity symbiosis can be developed and used in an energy analysis. Thus, the model can be imported into energy analysis software in order to define environmental conditions and conduct a solar analysis accordingly. Research method, and the figure 1 is the framework of this study. And first is research problem. To collect actual environmental data such as sunlight and shading during the development of fishery electricity symbiosis, a beam can be used to analyze any shading that may affect the symbiosis. In this study, a beam for fishery electricity symbiosis was built using Revit, and the beam was integrated with geographic model using the inference work software so as to conduct the sunlight simulation and assess shading while taking into account the simulation result and the existing shading reducing solution. And next is beam development. To perform a sunlight simulation and shading assessment, taking into account the actual size of the fishery electricity symbiosis facilities and any surrounding structure that was likely to block sunlight, a beam of the facility and the utility post in its vicinity was built using Revit. This model took into account the components of facilities. The beam also includes fish pond, depositories for pound, solar panel frames, solar panels, surrounding roads, and utility posts. To ensure that the sunlight simulation was performed in a virtual environment similar to the fishery electricity symbiosis facility's actual location, the coordinate of the facility were set to 23 degrees 19 minutes 49.1 seconds north and 120 degrees 11 minutes 52.5 seconds east in frameworks to develop a geographical model for this case. The beam of the fishery electricity symbiosis facilities was then imported into frameworks to provide the model's coordinates. Thus, the beam and geographical model were merged through the framework's coordinate system. Figure 3 depicts the result of the sunlight simulation performed in this study. To extend the influence of shedding from surrounding structure on the fishery electricity symbiosis facilities, a sunlight simulation of the facilities was performed at a key time throughout a whole year, using the sun and sky feature of inference work. Specifically, the simulation was performed between 7 a.m. and 5 p.m. on the summer is the longest sunlight day, and the winters the shortest sunlight day, solstice of that year, to extend the shedding situation while the facility was being developed. And the figure 4 is illustrate the sunlight simulation performed for the winter solstice. The simulation results indicate that the preponderance of shedding at the fishery electricity symbiosis facilities during the winter solstice was due to the solar panels' angles of elevation. This led to high difference between the panels and caused those at higher position to shed those at lower positions. Therefore, the solution was devised to reduce this module shedding. This involved widening the horizontal gaps between the frames of solar panels from 3.8 meters to 5.5 meters. It is over there. The extent of shedding was estimated at different hours for the current and proper solutions, and figure 6 show that the proper solution led to wider gaps between solar panel frames, allowing the panels to sustain less module shedding than previously. And that's its conclusion. The result of the shedding assessment suggests that by importing a beam into frameworks to conduct a sunshine simulation, one can extend the design of the fishery electricity symbiosis facilities, identify its limitation, and develop a solution accordingly. This can provide a basic understanding of how the facilities is designed and help to analyze the whole design process. Moreover, a shedding assessment can be timely performed while taking into account the existing solution to reduce shedding for the facilities. This can help to determine the effectiveness of other similar solutions. Thanks for your listening.
Okay.